Hi folks, today we're going to talk about solving systems of inequalities by graphing. So we kind of bring back the graphing and the pictorial representation of what these systems look like, but instead of lines this time we're talking about inequalities. So we could have some lines, we could also have some other things, but the inequalities on a graph are going to involve shading. So the process today is to graph each inequality, but you need to graph it on the same graph. So graph each inequality on the same coordinate grid. Some cases, for example, the first example, second equation, is not solved for y. So you might have to solve for y to make graphing easier. Maybe try and put it in slope-intercept form, y equals mx plus b, or in this case, y is less than, greater than, or equal to blah, 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 mx plus b. After you graph, you need to shade the portion for each solution region. Every equation is going to have shading. So I have the information for you to fill in. The greater than or equal to sign is a solid line shaded above. Above because the solutions are greater than, and solid because it has the or equal to part. So we could have solutions on our line. The second inequality sign is the greater than sign. That's a dotted line shaded above. Above because we still have the solutions that are greater than the line, but dotted because we don't have the or equal to part of our inequality. So we don't have solutions on a dotted line. The easy way to remember that is that points for a solution could easily fall through a dotted line, so they can't be on a dotted line. The third inequality symbol we have shown is the less than or equal to sign, which means we've got a solid line and shading below. So solid because it has the or equal to, and below because the values for the solutions are less than the line. And then finally, the less than sign indicates a dotted line and shading the region below. After you shade, the solution to the entire system is going to be in what we call the overlapping shaded region. So it has to have shading from all of the inequalities that you graphed. Okay, so let's scroll down to the first example. For the first example, we want to go ahead and start graphing our inequalities that are in the system. Notice that we have 3, and notice that the first one is kind of in slope-intercept form. We have mx plus b here. So let's go ahead and graph, starting with the y-intercept of -4, and a slope of 2/3. So I'm going to rise 2, run 3. Rise 2, run 3, rise 2, run 3. I can extend this from the y-intercept and go down 2 and back 3, down 2 and back 3, down 2 and back 3. I can use my shapes tool to draw the line, but I need to make sure that my line is supposed to be solid here, because if it's supposed to be dotted, I don't have a tool in the shapes tool area that will do that. So I look at my inequality sign. I notice that my inequality is greater than or equal to, which means that I need a solid line here. The or equal to is what makes the solid line necessary. So I'm going to graph my line. I'm going to put some arrows on the end of that. And then I'm going to look at the shading. So because this is the greater than or equal to sign, that means I need to shade the values that are greater than the line or above the line. I'm going to go ahead and change the transparency of my shading, and I'm going to make it much thicker than the tool that I was writing with. So if I want to shade above, that means that I go to any point on my line and I go directly above, and that means that this space is the above space. So I'm going to take my tool and I'm going to shade all of this space above, because this is where my solutions are for the first inequality. Okay, so now I'm going to move ahead to the next one. I need to change my transparency back and change my writing thickness, so maybe we'll put it back there. So for this inequality, I notice that it doesn't start out with y, which means I'm going to have to solve for y. So if I want to get y by itself, I need to move the other term with inverse operations. I have 2y is less than or equal to negative x and a positive 10. I'm going to divide all sides by 2, all terms by 2. I have y is less than or equal to negative 1/2 because there is an invisible 1 up there as the coefficient. X jumps out to the side. And then plus 10 over 2, which is 5. So when I graph this, my y-intercept is at 5. My slope is negative 1/2, so that means I go down 1 and over 2. Down 1 over 2. I keep going until I can't go anymore. I can extend this up 1 and back 2. So I'm going to go ahead and do that. And before I use the drawing tool, or sorry, the shapes tool, I need to see what kind of line I have. So I have y is less than or equal to my line. That means I need to shade below because I need the less than values. And it means that I need a solid line. So I can go ahead and use my shapes tool, make it blue, and there we go. And I'm going to go back to my drawing tool. I'm going to change my transparency. I'm going to change the thickness, and I'm going to shade. So that symbol is less than or equal to. That means I need to shade the less than values from that line, so the bottom part of that line. I'm going to shade all of this. So right now, that overlapping shaded area is the stuff that's on the left side. Okay. And finally, we're going to move to the last one. I'm going to change my transparency back. Oh, sorry, I'm going to do yellow. Change my transparency back. Change my thickness back. And I have the line with the shading, x is greater than 2. So that means that all of my x values on the line are 2. So here's 2, right? And that's all of these up and down this vertical line. And I don't have the or equal to sign, it's just strictly greater than. So that means this needs to be a dotted line. So I'm going to draw a dotted vertical line going through an x value of 2. And my inequality symbol is greater than. And since my inequality symbol is greater than, that means that I need to shade the greater than values. But in this case, I can't shade above a vertical line. Shading up here would be silly. So I'm going to shade the line, the area that's greater than 2 on the x-axis. So over here to the left of 2, those are values that are less than 2. I want the values that are greater than 2. So I'm going to shade the area that's all over here to the right. So what I'm looking for is I'm looking for the overlapping shaded area. And the overlapping shaded area in this problem happens to be this little triangle that is right here. So this triangle in the middle, this is the overlapping shaded area that we have. And that's where all of our solutions are going to fall to this system of equations. So I'm going to go back and change my transparency, change my line, change my writing. Okay, so I need to know if the following solutions, following points for this system I need to know if the following points are solutions for the system of inequalities. So the point 3, negative 2 is 3, negative 2 right here. That's not quite in my shaded area, but it is on a solid line, and it is in the other 2 shaded areas, so I'm going to say this is a solution because it's in the overlapping shaded area. The point 2, 4 is right here. It's in the red shaded area. It's on a blue solid line, that's okay, but it's on a yellow dotted line, and so that is not a solution to the system because it's not a solution to the yellow graph. The point 5, 1, 5, 1 is right here. That falls right in the middle of our shaded area, so yes. And finally, the point 8, 1 falls right here. That is on a solid a solid red line, a solid blue line, and it's in the yellow shaded area. So that is a solution to my system. Okay. So So I'm going to go ahead and scroll to my next example. I'm going to follow my same steps. I only have 2 equations this time, but neither of them are solved for y. So I'm going to go ahead and solve for y. They're in something right now called standard form that you hopefully learned about last year. So to solve for y, I'm going to move the other term. I have 3y is greater than or equal to negative 2x plus 9. I'm going to divide everything by 3. And I have y is greater than or equal to negative 2/3 x plus 3. So I'm going to graph the y-intercept of 3. I'm going to use my slope of negative 2/3, so down 2 and the right 3, down 2 and to the right 3. I'm going to go up 2 and left 3 to extend the line backwards. There we go. I notice that my inequality sign is greater than or equal to. So greater than shaded above or equal to solid line. Solid line. Okay. And then if I shade above, then I'm going to change my transparency. There we go. And I'm going to make that a little bit thicker. I'm going to shade above. Oop. There we go. So all of this is a solution to that first inequality. So for the second inequality, I'm going to have to do something similar. It's kind of in the same form. It's not solved for y, so I want you to, once you finish shading, pause the video and try to solve for y and graph the inequality, including its shaded solution set. So pause your video and try the next equation. Okay, so hopefully when you solved that second equation for y, hopefully you realized that when you solved, you had to get rid of the negative that was in front of the y. So you had to divide everything by -1, which meant that you're going to flip the inequality sign, and instead of being less than or equal to, it will now be greater than or equal to, right here. So whenever you graph your line should have a positive slope. It should have a y-intercept of -5. It should be a solid line because the inequality sign had the or equal to, and we should be shading above, which means that our inequality sign had the greater than. So my double shaded area is that top triangle that both both the red and the blue kind of overlapped with. So I need to know, are the following points solutions for the system of inequalities? So the first point is 6, -1. If I graph the point 6, -1, I end up right here. That's on the red shaded area, the red solid line, but it's not on the blue, so it's not a solution to the system. It's got to be a solution for both. The point 1, 3 is right here. That's in the double shaded area. That is a solution. And the point 4, 2 is right here. That's in the red shaded area, but not the blue shaded area, so no, this is not a solution to the system. Okay, so let's move on to example 3. Example 3 is kind of interesting because we end up having this absolute value in our inequality. So let's graph that one first. So it's nice that it's already solved for y. I notice that it almost looks like transformations are happening from the parent function, the absolute value parent function. Remember, that's a v with a vertex at the origin, and it looks like we have shifting 4 to the left. It looks like we have shifting 3 up. It looks like we have a reflection over the x-axis. And you have a vertical stretch by 2. By 2. Okay, so there isn't any solving going on. I shouldn't have drawn that arrow there. But we do have these transformations happening. So I'm going to start at the origin, and I'm going to move to the left 4. So that's my H change. So to the left 4. I'm going to move up 3. Here's up 3. Here's my vertex. I need my graph to be opening down because I have a negative out in front. And I need my graph to be vertically stretched by 2, which means instead of going to the right 1 and down 1, I'm going to go to the right 1 and down 2 because I'm stretching by 2. So I'm going to go to the right 1 and down 2, to the right 1 and down 2, to the right 1 and down 2. Now I need to make the other part of my V. So instead of going to the right, now I'm going to go to the left 1 and down 2, to the left 1 and down 2. So you're creating the other side of your V for the absolute value equation. I notice the inequality sign is less than or equal to. The or equal to part tells me that I can go ahead and use a solid line. So I've got a solid line here for that side of the V, and I have a solid line here for that side of the V. Put my arrows. Finish connecting this because my line didn't connect. Okay, and because it's less than or equal to, that means that I'm going to change my transparency and I'm going to shade the less than values. And those less than values are going to be below the graph. So that would be all of this area right here. Okay. The way you tell those less than areas is you pick a point on your graph and you go straight down. You land in the less than area. All right. So now let's look at that second equation, or sorry, inequality. It's not solved for y, so we're going to go ahead and solve for y. We're going to move x. We have negative 2y is less than negative x plus 4. I'm going to divide all sides by negative 2. When I divide by a negative, that means I switch my inequality sign. I have 1/2 x minus 2 as the expression for my line. So I start at a y-intercept of negative 2. I rise 1, I run 2 because my slope is 1/2. Down 1, left 2, down 1, left 2. Continues to the other side. I have the greater than symbol for my inequality, which means I need a dotted line because there's no or equal to. So that's easy to make. And then my shading, because it's a greater than sign, is above. So I'm going to change my transparency. And I'm going to shade above the line. So if I pick a point on the line, I go straight up. That's the above area. So I'm going to shade all this. And I notice that the overlapping shaded area is kind of that little triangle that's in the middle there. So I'm not going to shade all of this, even though it's supposed to be shaded. But I am going to shade this little triangle area, because that's my solution set for the system. There. So I want to know if the following points are solutions to the system. Are they in the overlapping shaded area? Well, the point -4, -4 is right here. That's in the red shaded area, but that's on a blue dotted line, and that's not in the solution set, so no. The point 3, 1, I didn't even finish shading that blue area, and it's not in the red shaded area, so no, this is not a solution. The point -8, -3, that point is in the blue shaded area, but not the red shaded area, So this is not a solution to the system. And finally, the point -2, -4. That is in the red shaded area, but not the blue shaded area. So none of these are in the solution set. And that's okay. All right. So the last type of example that we have like this is example 4. I do want to warn you, maybe not warn you, but let you know, that this is not solved for y, but whenever you solve for y, you want to move that absolute value over all in one piece. So you want to add the absolute value of x minus 3 and add the absolute value of x minus 3. It's kind of like parentheses. It's got to all stay together. So 3y is less than the absolute value of x minus 3 plus 3. And then you have to divide all terms by 3. So we have y is less than 1/3 out in front, absolute value, x minus 3, plus 3/3, which is 1. So if you think about transformations, this is a shift to the right 3, a shift up 1, and this is a vertical compression by 1/3. So I'm going to shift from the origin to the right 3 and up 1. And my vertical compression of 1/3 means that instead of going to the right 1 and up 1, I go to the right 1 and up 1/3, to the right 1 and up 1/3, to the right 1 and up 1/3. And I notice that what's really happened is I go to the right 3 and up 1. So that seems much easier than doing the counting by 1/3. So over 3 and up 1. Over 3 and up 1, over 3 and up 1, over 3 and up 1. So that makes the V part easier. My symbol is the less than sign. There's no equal to, so that means that I have a dashed or dotted V. And since it's the less than sign, that means that I need to shade below. I'm going to shade everything below. Okay. And then for the other equation, I have x is greater than or equal to 3. So that's another equation with just 3's for the x's. So 3's for the x's. That's a vertical line. It is solid because the inequality sign is greater than or equal to. So I'm going to draw a solid line. Because it's greater than or equal to, that means that my shading needs to shade the greater x values, which are to the right. So I'm going to shade all of these x values. So that overlapping shaded area is kind of this bottom right portion of the graph, that right there. So when I look to see if the points that are given to me are solutions, the first point is 6, 2. That's right here. That's in the blue shaded area, but it's on a dotted red line, so that's not a solution. The second point is 3, -5. So that's right here. That's in the red shaded area and on a blue solid line, so that is a solution. And finally, 6, -2 is right here. That's right in the middle of that overlapping shaded area. So the last problem that we have today is example 5, and instead of giving you inequalities and asking you to graph them, it gives you the graph and asks you to write the inequalities. So if you notice, there are 3 lines. One of them is horizontal, one of them is sloped positively but dotted, and another one is sloped negatively and solid. So I'm going to go ahead and start out with y. Maybe let's do the horizontal one first. So the horizontal line has all y values that are 1. So y is something to 1. It looks like the shading is above because this is the overlapping shaded area. So the shading is above and the line is solid. In another equation, let's go ahead and do the dotted line. In the dotted line, that y-intercept is -1. That slope, if I start here and I end here, is 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3. So 9 over 3 is 3. It's a dotted line, so there's no or equal to part. And it looks like the shading is to the right, kind of, but the right is really the down area. So less than. And then finally we have that solid line. So the y-intercept is 7. The slope from point to point, if I go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 over 9 simplifies to 2 over 3, but it is a negative slope, so -2/3. My shading looks like is down, so below, and my line is solid, so or equal to.